Hi, everybody. We only have 2 units left in our school year. We have our real numbers that we're going to start today, and it's a super quick couple day unit. And then we have polynomials. So, first of all, I miss you all. I wish we were together. Unfortunately, I know we can't be for the rest of this year, but hopefully I'll be able to see your smiling faces in some capacity for some sort of moving up experience for you. And I just want to say congratulations on how hard you've been working and everything that you've been able to accomplish at home. You really should be proud of yourselves. So today we're talking about rational and irrational numbers. So we have what we call our real number system. Now you might be saying, well, Mrs. Rose, aren't all numbers real numbers? Yes, they are, but we also have a set of numbers called imaginary numbers that you learn about in high school. And those are like I, negative I squared. Maybe if you have an older sibling or something, you have heard them talk about imaginary numbers, but we talk about the real number system in middle school. And the real number system is divided into 2 subsets of rational numbers and irrational numbers. Rational numbers are any number that can be expressed as a fraction, okay, or we say terminating or ending decimals. Okay. Irrational numbers, they're crazy. They're irrational. Those are numbers like pi, things that decimals that don't terminate. So then under rational numbers, you have fractions and decimals, and you have integers. Under integers, you have whole numbers, and then under whole numbers, you have natural numbers, which are also sometimes called counting numbers. Okay. So counting numbers. So you read this chart kind of from the bottom up. So whole numbers are also integers, rationals, and real numbers if you follow the lines. Natural numbers are whole, are integers, are rational, are real. Irrational are only also part of the real numbers. So if I'm an integer, I'm automatically rational and real. So I'm automatically part of what comes above me. So I think of this like a team. And these are my most select or my best players. They can play anywhere. It's like my starters. And then this would be the name of my team. And this would be my second string, third string, fourth string, so on and so forth. I might take this first line player or my starter and play them on my third line. So a natural number is also an integer. But I wouldn't take a third, if I want to win, I wouldn't normally take a third line player and put them in the first line. Normally coaches don't do that. Could it happen? Sure. But normally it doesn't. So that's how I make sense of it. So my best players can play anywhere. And then as I go up, this might be my, let's see, 1, 2, 3. This would be my fourth line player. So they wouldn't play on my more select lines, but they are part of my team. So rational numbers and real numbers. Again, just how I think about it. You can think about it any way you want, or just remember to read up the chart. So natural number is whole, integer, rational, real. So you are automatically part of the set that comes above you. So then all the sets are described. A natural number, like I said, is a counting number. That's 1, 2, 3, 4, 5, 6, 7, all the numbers you count with. The dot, dot, dot means it goes on forever. Then you have your whole numbers, which is all your natural numbers, plus the addition of 0. Normally when we count, we don't start with 0, we start with 1. So natural numbers start with 1. Whole numbers are all of the natural numbers plus the number 0. Integers are all of the whole numbers plus their opposites or their negatives. Rational numbers include all of our fractions, so any repeating or terminating decimal. Okay, now repeating is different than having a pattern. Like a pattern might be 1, 2, 1, 1, 2, 1, 1, 1, 2, 1, 1, 1, 1, 2. That's a pattern. That does not mean that it is rational. A pattern is not the same as repeating. I cannot put a bar over any of these, which means it is not rational. It must repeat, meaning you must be able to put that bar over top of the decimal portion. So we remember a trick for rational. we say repeating and terminating decimals. Okay, and you can always check on your calculator. You could put the decimal in and hit the fraction decimal button. If it changes into a fraction, then it's rational. If the calculator gives you back the decimal, it means it can't be changed into a fraction, therefore being irrational. So I always think about irrational as being like our wild numbers. If you've ever been in a fight with your parents and they say, "Oh, you're being so irrational," okay, well, that means you're, being a little wonky. So these are our irrational numbers. Our most famous irrational number is pi. So they don't end and they don't repeat. But like I said, they might have a pattern like this one here. Real numbers are any number that can be written as a terminating or non-terminating decimal, or any positive or negative number in any rational or irrational number. So real numbers are basically all the numbers that you know of at this point in your mathematical career. So let's take a look at what we have. So we want to state what these numbers are. So we want to know, are they natural, whole, integer, rational, irrational, to which each real number belongs. So we know that they're all real. So we want to state everything that applies. For instance, the number 3. So I know that the number 3 is a counting number or a natural number. Okay. I know that the number 3 is also a whole number. There's no parts or pieces with it, no decimals. I also know that it's all of the things above it. So it's also an integer. And it is also rational. And it's also real. So it's all of them. So if I go back to that chart, you can see that because it was natural, it was here, it was natural, it's automatically everything above it: whole, integer, rational, real. So basically, if you can figure out where it starts, you can know that it's part of everything that would come above it. Okay, so let's take the number -4. Well, do I use the number -4 when I count? No. So it's not a counting number or a natural number. Is it a whole number? Nope, not whole. Is it an integer? Yes, it's an integer. Let me switch colors here. So it's an integer, which also means that it is rational and real. Okay? The number 0. Not natural, but it is whole, and then it's everything above it. So it's whole, it's an integer, it's rational, and it's real. The number 5.6. Well, it's not natural because I don't count with decimals. It's not whole because it has a piece here. This 0.6 is 6/10. It's not an integer because integers don't have any parts or pieces. So it is rational and real. I'll show you. Okay, so it's fraction decimal and then rational and real. I don't think fraction decimal was one of our... Nope, so it's just rational and real. So I'm going to say rational and real. This repeats, so it is also rational and real. Now the square root of 15, I'm not so sure about that. So I'm going to have to get my calculator, and I'm going to put in, I can't reach it. I'm going to put in the square root of 15 in my calculator, and it gives me this wonky number. It gives me 3.8729833346. Well, now I'm confused because I don't know if my calculator screen just ended, if this goes on, did it round? I have no idea. So this is where this fraction decimal button on your calculator comes in. So I'm going to see if I can turn this into a fraction. I cannot turn it into a fraction. I hit fraction decimal, it gave me back the decimal. So I know that this is irrational. If it gave me back a fraction, I would know it was rational and real. But it is irrational, and it is also real. Pi is my most famous irrational number. It is also real. Okay, what do you think about number 8? Go ahead and try that now. Okay. So number 8. Hopefully you picked that it is not natural because it has a piece and it's negative. We don't count with negative numbers. It's not whole because it has a decimal portion. It's not an integer because it has a decimal portion. So this one would just be rational and real. Okay, try number 10. Again, rational and real. Try number 16, or sorry, number 11, the square root of 16. Okay, well, square root of 16 is really 4. So we have natural, whole, integer, rational, and real. Try 14. 14 is rational because I can put a bar over it, and real. Okay, let's move on. Okay, state whether it's rational or irrational. Remember, if I can put a bar over it, if it repeats, it's rational. So this, I can put a bar over, so it's rational. This ends, it's rational. This does not end, and I cannot put a bar over it, so this would be irrational. This has a pattern to it, but I can't put a bar over it, so it's irrational. What's number 20? Should be rational because it ends or terminates. Okay, and we did, sorry, I'm just marking down on my paper which ones I'm having you guys do. How about, let's do 21 is really the square root of 25, which is 5. That's rational. 22 is rational. Let's have you guys do 23, the square root of 101. So see if you can figure that out. Use your calculator to help you. And then use that fraction decimal button. And hopefully you pick that it's rational. It can actually be written as a fraction. Okay, now you're doing greater than, less than, or equal to. So you, again, are going to need your calculator. So I have 1.7 and the square root of 3. So if I have, let's see, 1.7 and the square root of 3. So I'm going to calculate the square root of 3. And then I'm going to see if I can change it into a fraction, which I cannot. So 1.7 and this, so I know this is irrational, and I know as a decimal that it's 1.73205, and I know that's going to continue on. So I'm going to say that it is bigger because 1.7 is less than 1.732, blah, blah, blah. So now I'm going to try the square root of 6, which is 2.44, and a half is 2.5. So it's this. Okay. Try number 29. Okay. Square root of 55 is 7.41619. And then I have 7.422. So same. I'm comparing now this 1 and this 2. Well, 2 is bigger, so therefore 7.42 repeating is bigger. Okay, that's really all that we're doing. So let's see if we got anything else we want to review on here. Nope, that's pretty much it. We have like 2 more days of stuff here, guys, and then this unit is over. So there's nothing for you to upload. You've answered the questions here in Edpuzzle. So I see all your work automatically. So there's nothing else you need to do for math today. Have a good day.